Math for AI. Overview. Learning objectives. By the end of this unit, you will be able to understand the significance of mathematics in building and training artificial intelligence systems. Identify and apply mathematical patterns in numbers, shapes, and real-life contexts. Use statistics to collect, organize, and interpret data meaningfully. Recognize the application of linear algebra in processing visual and audio data. Calculate and apply probability to assess the likelihood of events. Explain the role of calculus in optimizing artificial intelligence models for improved predictions. Importance of math for artificial intelligence. Importance of math for artificial intelligence. Mathematics forms the core of artificial intelligence. Artificial intelligence systems analyze various types of data, like photos from security cameras, sound recordings from smart assistants, or text from social media, to find patterns or connections. These patterns help artificial intelligence to learn, make predictions, and take decisions automatically, such as recognizing faces in photos or suggesting songs you might like. Key areas of math used in artificial intelligence. Statistics helps artificial intelligence summarize and understand data trends, such as analyzing customer buying habits on e-commerce websites. Linear algebra deals with vectors and matrices, which are essential in representing images and videos for artificial intelligence in apps like Google Lens. Probability used to predict the likelihood of outcomes, like estimating the chance of a power outage during a storm based on weather data. Calculus helps artificial intelligence models improve by optimizing functions, for example, refining voice recognition accuracy in virtual assistants. Finding patterns in numbers and images. What are patterns? Patterns are recognizable arrangements of numbers, shapes, colors, or sounds that repeat in a predictable way. Simple versus complex. They can be simple, like the black and white stripes on a zebra, or more complex, like the spiral patterns seen in sunflowers and seashells, which follow the famous Fibonacci sequence, a natural math pattern found all around us. Why are patterns important in math? Patterns are the building blocks of math, helping us to solve problems. Recognizing patterns makes problem solving easier. For example, spotting patterns in a multiplication table lets you calculate faster, just like artificial intelligence learns from data to solve complex problems quickly. Develop thinking skills. Searching for patterns helps us think logically, analyze information, and connect different ideas. For example, music composers use patterns in rhythms and notes to create songs. Uses of math for AI. Uses of math in artificial intelligence. Mathematics is the foundation of artificial intelligence. It enables machines to understand, learn from, and make decisions based on data. Artificial intelligence does not function based on guesses. It uses precise mathematical logic to recognize patterns, make predictions, and solve problems. The four key branches of mathematics used in artificial intelligence are statistics, linear algebra, probability, and calculus. Statistics in artificial intelligence. Statistics allows artificial intelligence systems to analyze large amounts of data and discover meaningful patterns. It is especially useful when artificial intelligence needs to summarize information and make decisions from data. Example: Amazon uses statistical analysis to recommend products. If a customer buys a phone, the artificial intelligence may suggest phone covers or headphones based on patterns in past purchases by similar users. These suggestions are not random, they are based on statistical probabilities derived from massive datasets. Linear algebra in artificial intelligence. Linear algebra deals with vectors and matrices. This is crucial for artificial intelligence models that work with images, videos, and audio, because these types of data are converted into numerical formats. Example: Facebook's face recognition system uses linear algebra to identify people in photos. When you upload a group photo, artificial intelligence breaks down each face into a set of numbers using matrices and compares these with saved data to recognize and tag individuals correctly. Probability in artificial intelligence. Probability helps artificial intelligence deal with uncertainty by predicting the chances of certain events happening. This is especially useful in situations where outcomes are not guaranteed. Example: Ola and Uber use probability to estimate traffic conditions. Before suggesting the fastest route, the artificial intelligence calculates the likelihood of encountering traffic jams based on past travel data, weather conditions, and time of day. This helps the system guide drivers and passengers more effectively. Calculus in artificial intelligence. Calculus is used in artificial intelligence for optimization, improving how artificial intelligence models learn from data. It helps in adjusting the models step by step to get the best performance. Example: YouTube's recommendation engine uses calculus-based optimization to fine-tune its algorithms. By observing user behavior, like how long a video is watched or how often users click like, the artificial intelligence adjusts its model continuously to recommend better, more relevant videos over time. Applications of statistics in real life. Statistics plays a crucial role in various real-world applications. Disaster management. Authorities use statistics from past earthquakes to plan safe building zones and emergency responses. Sports. Coaches analyze player statistics, like run rates or passing accuracy to improve team strategies in cricket or football. Disease prediction. Health officials track infection rates over time to predict and control outbreaks, like monitoring dengue fever cases in urban areas. Weather forecasting. Meteorologists use historical weather data and statistics to predict rainfall and temperature changes. Number patterns picture analogy. Picture pattern puzzles. Image pattern. Image pattern. Observe the sequence of images. What comes next? Answer will be. Hint: it's repeating every 3 shapes. Weather icons. Weather icons. Observe the sequence of images. What comes next? Answer will be. Hint: weather cycle repeats every 3 steps. Number of vehicles per hour. Number of vehicles per hour. Observe the sequence of images. What comes next? Answer will be. Hint, multiply by 2. Example. Puzzle 1. Simple addition pattern. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Puzzle 2. Multiplication pattern. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Puzzle 3. Subtraction pattern. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Puzzle 4. Square numbers. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Puzzle 5. Fibonacci sequence. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Puzzle 6. Doubling and adding. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Puzzle 7. Reverse pattern. Observe the pattern. What is the answer? Answer. Rule for this pattern is. Statistics. What is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting data to make sense of information from the real world. It helps us summarize large amounts of data and draw meaningful conclusions. For example, during elections, polling agencies collect data from thousands of people and use statistics to predict who might win. Applications of statistics. Disaster management. Governments use statistical data from past events to prepare for disasters. For example, after analyzing the frequency and impact of floods in Assam, authorities can develop better flood warning systems and evacuation plans to save lives. Sports. Coaches analyze players' performance statistics like batting averages or goal-scoring frequency. For example, cricket teams use player stats to decide who to select for a match or which bowling strategy to adopt. Disease prediction. Health departments collect data on symptoms, infection rates, and recovery. For example, artificial intelligence models used during the COVID-19 pandemic analyzed case numbers and trends to predict hotspots and help manage resources. Weather forecast. Meteorologists use historical weather data to predict rainfall, storms, or heat waves. For example, the Indian Meteorological Department uses statistics to forecast the monsoon and alert farmers accordingly. Uses of statistics in daily life. Statistics plays a big role in many fields, helping us understand and improve the world around us. Here are some new examples. Traffic management. Cities collect data on vehicle flow, at different times to reduce congestion. For example, smart traffic lights use statistics on traffic patterns to change signal timings and reduce waiting times. Healthcare monitoring. Hospitals use statistics to track patient recovery rates and identify which treatments work best. For instance, analyzing data from thousands of patients helps doctors predict who might develop complications. E-commerce recommendations. Online shopping websites analyze customer browsing and buying habits using statistics to suggest products you might like, making shopping faster and more personalized. Environmental conservation. Scientists gather data on animal populations and weather changes to predict the effects of climate change and design conservation plans. Movie and music streaming. Streaming platforms collect data on what you watch or listen to and use statistics to recommend new songs or movies that match your taste. Probability. What is probability? Probability is a way to measure how likely or unlikely an event is to happen. It gives us a number between 0 and 1 that shows the chance of an event occurring. If the probability is 0, it means the event will never happen. If the probability is 1, it means the event will definitely happen. Any number between 0 and 1 shows how likely the event is. The closer to 1, the more likely; the closer to 0, the less likely. Example. Think about tossing a fair coin. There are two possible outcomes, heads or tails. The probability of getting heads is a half or 0.5. This means there is an equal chance of getting heads or tails. How to calculate probability? Probability tells us how likely an event is to happen. To calculate it, we use this simple formula. Probability of an event is equal to number of favorable outcomes by total number of possible outcomes. Favorable outcomes are the results you want. Possible outcomes are all the things that could happen. Example. Rolling a dice. Imagine you roll a fair six-sided dice. The sides show numbers 1, 2, 3, 4, 5, and 6. What is the probability of rolling a 4? The number of favorable outcomes is equal to 1. The total number of possible outcomes is equal to 6. So, the probability is 1 by 6 is equal to 0.167 or 16.7%. This means you have a 16.7% chance of rolling a 4. Types of events. Certain event. An event that will always happen. For example, the sun rising tomorrow is a certain event. Impossible event. An event that can never happen. For example, rolling a 7 on a standard six-sided dice is impossible. Likely event. An event that has a good chance of happening. For example, getting rain during the monsoon season in your city is likely. Unlikely event. An event that has a small chance of happening. For example, winning a big lottery is unlikely. Exercise. Identify the type of event. Getting heads when flipping a fair coin. Type. Likely event. Reason. There is a 50% chance of getting heads because the coin has two equal sides. Finding a blue car in your neighborhood. Type. Likely event. Reason. If blue cars are common, the chance is high but not certain. Earthquakes occurring in your area tomorrow. Type. Unlikely event. Reason. Earthquakes are rare and unpredictable, so the chance is usually low. Passing your next exam if you study well. Type: likely event. Reason: studying increases the chance of passing, so it is more likely than not. Applications of probability in real life. Sports. Coaches use probability to decide strategies. For example, in football, the chance of scoring from a penalty kick can influence game tactics. This analysis helps in deciding player positions and defensive formations, increasing the team's chance of winning. Similarly, in cricket, the probability of scoring runs or getting out on a particular type of ball influences the batsman's decision-making during a match. Weather forecasting. Meteorologists use probability to predict the chance of rain or storms. For instance, a 70% chance of rain means it's quite likely you'll need an umbrella. This not only saves time but also reduces fuel consumption and air pollution, making daily commutes more efficient. This helps farmers decide when to plant or harvest crops, plan irrigation, and prepare for possible weather disruptions. Traffic estimation. Navigation apps like Google Maps calculate the probability of traffic jams based on historical data and current conditions to suggest the fastest route. This not only saves time, but also reduces fuel consumption and air pollution, making daily commutes more efficient.